want this? You want this? You want this? This.
Science and Engineering, University of Moratuwa, Sri Lanka. Internet of Things, IoT, SLIoT Challenge 2025, SLIoT future, SLIoT future and computer science and engineering every day of Moratuwa. Internet of Things, IoT, SLIoT Challenge 2025, SLT model, Internet. Internet of Things, IoT, SLIoT Challenge 2025, SLIoT the future, SLIoT future and computer science and engineering every day, Moratuwa. SLIoT Challenge 2025, SLT Mobile, Department of Computer Science and Engineering, University of Moratuwa, Sri Lanka. Internet of Things, IoT, SLIoT Challenge 2025, SLIoT Mobile, future. SLIoT Challenge 2025, SLT Mobile, Department of Computer Science and Engineering, University of Moratuwa, Sri Lanka. Internet of Things, IoT, SLIoT Challenge 2025, SLIoT the future, SLIoT future and computer science and engineering every day of Moratuwa. Internet of Things, IoT, SLIoT Challenge 2025, SLT model, Internet. Internet of Things, IoT, SLIoT Challenge 2025, SLIoT the future, SLIoT future and computer science and engineering every day, Moratuwa. computer science and engineering, University of Moratuwa, Sri Lanka. Internet of Things, IoT, SLIoT Challenge 2025, SLIoT mobile future. SLIoT Challenge 2025, SLT Mobile, Department of Computer Science and Engineering, University of Moratuwa, Sri Lanka. Internet of Things, IoT, SLIoT Challenge 2025, SLIoT the future. SLIoT, future and computer science and engineering every day. Orange me. Internet of Things, IoT, SLIoT Challenge 2025, SLT mobile, internet. Internet of Things, IoT, SLIoT Challenge 2025, SLIoT the future. SLIoT, future and computer science and engineering every day. Orange me. Future me. I'm orange me. SLIoT Challenge 2025, SLIoT my future. SLIoT, fortune of computer science and engineering everything. You'll orange you need. Orange you need. SLIoT Challenge 2025, SLT mobile, Department of Computer Science and Engineering, University of Moratuwa, Sri Lanka. Internet of Things, IoT, SLIoT Challenge 2025, SLIoT mobile future. SLIoT Challenge 2025, SLT mobile, Department of Computer Science and Engineering, University of Moratuwa, Sri Lanka. Internet of Things, IoT, SLIoT Challenge 2025, SLIoT the future. SLIoT, future and computer science and engineering every day. Orange me. Internet of Things IoT. SLIoT Challenge 2025. SLIoT till the future is future. SLIoT, future and computer science and engineering forever radio run to me. Future name. I'm more run to me.
A very good morning to all of you. We warmly welcome you all to the SLIoT Challenge 2025, a university and open category workshop. I'm Moindu Atukorala.
And I'm Satsarani Amarasinghe, and we will be your hosts for today's program.
The SLIoT Challenge is the annual IoT competition organized by the Department of Computer Science and Engineering at the University of Moratuwa in collaboration with SLT Mobitel and the Institution of Engineers Sri Lanka.
This initiative aims to foster innovation, creative problem solving, and provide a platform for young minds to explore the limitless possibilities of IoT technology.
To commence today's proceedings, we invite the chairperson of SLIoT Challenge 2025, Mr. Pavan Appa, to deliver the welcome speech.
Good morning, everyone. It's a pleasure to welcome you all to the SLIoT Challenge 2025 University and Open Category Workshop. As the chairman of this year's challenge, I'm excited to see so many bright minds ready to innovate with IoT technology. We are honored to have industry experts and top academics with us today. Mr. Ashane Fernando, Zone 24/7. Mr. Pasindu Liyanage, AI/ML expert in Cisco Labs. Dr. Chaturanga Hettiarachchi, Senior Lecturer, Department of Computer Science and Engineering. And Professor Chandana Gamage, Senior Lecturer, Department of Computer Science and Engineering. So take this chance to learn, ask questions, and collaborate. The ideas you develop today could become innovations that change the future. I wish you all the best for the SLIoT Challenge 2025. Let's create something amazing together. Thank you.
Thank you, Pavan, for those insightful words. Up next, we have a sponsor video from SLT Mobitel showcasing their incredible contributions and support.
Are the building blocks of humanity, of progress, of hope, connecting, empowering, creating the new. We are the network of a nation, architects of symbiotic connections that have inspired and evolved Sri Lanka and the region for over 165 years. In our DNA is a network of firsts, pioneers, catalysts, challengers, and always ready. Fortified by the largest land and mobile telecom powerhouse. we employ a network of strengths, an omnipresent enabler, transforming the high-rises of global capitals, orchestrating, kindling, a new age of capabilities, delivering best-in-class technology to facilitate ideas, broaden opportunity, uplift infrastructure, accelerated by innovation, fortified by commitment, proven by legacy, interlacing air, land, and water, driving our steadfast philosophy to always be ahead of time. We offer a network of opportunity. Our ambitions touch every moment, every individual, every household, every enterprise dream. An ecosystem of agile limbic solutions, synchronized perfectly, understanding, learning, resolving, evolving, bridging the gulf between dreams and promises delivered. We believe in a network of hearts, sustainability, inclusivity, co-connectivity, encouraging new thinking. A network of the future, a bold, agile, far-sighted leadership that's driving Sri Lanka's digitization roadmap, giving credence to every individual, home, enterprise, and partner to build their vision of a smarter tomorrow. Because at SLT Mobitel, there's no dream too big. SLT Mobitel, the connection.
So we must acknowledge that this workshop would not have been possible without the generous support of our main sponsor, SLT Mobitel. Their unwavering commitment to technological advancement and education has been instrumental in making this event a reality.
We are privileged to welcome Ms. Niru Veerasinghe, who serves as the Engineer of Product Development and Management at SLT Mobitel. With over 10 years of experience in telecommunication industry, Ms. Veerasinghe has been pivotal in driving innovations and overseeing the development of cutting-edge products and services. Let's give her a warm round of applause as she shares a few words with us.
So, cheerful and an energetic good morning to all of you. So, ladies and gents, the distinguished guests, and our brilliant innovators. So, it's my absolute pleasure to address you in this SLIoT challenge. So, today we gather here to celebrate and remark the spirit of innovation and the boundless potentials of Internet of Things. So this event is a collaborative effort among SLT Mobitel, University of Moratuwa, and IASL. So together we are championing a future where the technology and creativity converge to shape a better future for us. So as SLT Mobitel, we are proudly sponsoring this SLIoT challenge, and our commitment is to foster the technological innovation and develop critical skills among Sri Lankan youth. So by supporting this challenge, we are investing in the future leaders and innovators of our nation. So as SLT Mobitel, we are always in the lookout of groundbreaking ideas and disruptive technologies based on IoT. So with these rapid advancements in technology, the widespread availability of broadband internet, and the proliferation of smart devices, IoT has already become a significant part in both business and personal spheres. So this challenge is far more than just a competition. It's a dynamic platform for you all to collaborate, learn, and grow. So it unites the brightest minds in our country together at one place. So by participating in this challenge, you are not only showcasing your talents, but you are driving the advancements and the technology of Sri Lanka. So as we embark on this exciting journey, I encourage all participants to embrace the spirit of innovation, and you may take this opportunity to learn from your peers and challenge yourselves, and also to think beyond the present. So the future of technology lies in your hands, and we are confident that you will do that. So I would like to extend my sincere thanks to all this organizing committee. Without your dedication, this won't be this much successful. And also I would like to wish all our participants very best of luck, and let's look forward for an exciting challenge throughout the time, and let's drive this future forward together. Thank you so much.
Thank you very much, Ms. Niru Veerasinghe, for your valuable insights. We truly appreciate SLT Mobitel's support in empowering young innovators.
Now it's time to kickstart our technical sessions. You can scan the QR code to submit any questions you have throughout the sessions to a Google form that we have provided to you. So your questions can be regarding the sessions itself or any other questions regarding the field. We will answer them at the panel discussion that is scheduled towards the end of the agenda. So just take a minute and scan the QR code that appears on the screen and submit your questions to the Google form.
Now please join me in welcoming Mr. Ashen Fernando, a senior electronics engineer at SON 24/7, renowned for his expertise in embedded systems and electronic payments. Mr. Ashen has significantly contributed to technological innovations, including the development of Alfred, an intelligent robot server enhancing restaurant operations. His commitment to knowledge sharing is evident through his recent keynote at the RoboNexus Workshop 4, organized by IEEE Robotics and Automation Society of Informatics and Institute of Technology. Let's give a warm welcome to Mr. Ashen Fernando.
As backwards as forward. Okay. Check one. Right, guys. With that, a very good morning to all of you all. I see some of you all are like, already not so good. So this is about sharing knowledge, right? It's about getting to know something that is important to your projects. So let's get excited, right? So good morning, ladies and gentlemen. Fine, something. I get some response. So at this session, ladies and gentlemen, I'll be talking a bit about product testing. Now, all of you all here, most of you all here, will be making your own product, right? You're doing some solution for a problem. Whatever solution that you will be doing, right, you will have to test it. You'll have to fix it. So I'll be talking about some technically methodical ways to do your testing as a product. Now before I'm going to start with all of that, most of you all are undergrads. I think all of you all are undergrads doing projects. But there are industry projects. So this is an actual instance that happened. Back in the day, if you know, a Boeing 747, yes, a Dreamliner, right? It's an aircraft. They had to reset this aircraft every 248 days. Why 248? It's a very odd number. Those of you who are programming or doing any sorts of programming knows that if there is a variable, if it's an 8-bit variable, what is the maximum number you can store in an 8-bit signed variable? 64,000 something, right, if I'm not mistaken. And if you go up to 16-bit, so on. I don't know if, okay, I think I made a mistake. I don't know if it's 16 or 8-bit, either way. So in this aircraft's firmware, there was a 32-bit variable. This 32-bit variable, if it is a signed variable, the maximum number that you can store in that variable is some 2 billion something, about 2.5 billion roughly. So apparently, when they were writing the firmware to this aircraft, which is going to be flying with people on board, right, this variable overflows. You know what a variable overflow is, right? Yes. This variable overflows after 248 days. Mind you, this variable is incrementing every 100 milliseconds. A variable that is incrementing every 100 milliseconds, and the maximum amount that it can store is 2 billion. That 2 billion gets saturated in 248 days. Now, obviously, if it's an aircraft, you can imagine the amount of tests they do. If it's a mobile phone, they will do some tests. But if a mobile phone fails, no one is going to die. Right? You get the logic there. Yes, if it explodes, one person may be damaged. But if you look at an automobile, a car, it's even more strict. Right? Because yes, it's still on the ground, but there are 4 people involved, there could be other people in a crash, things can go wrong. But an aircraft carrying 400 people, middle of the sky, what happens if the system resets? The amount of damage that can happen is unthinkable. So if Boeing company can miss something like this, worse things can happen to your products. Right? You can only imagine how systematic their testing is, but what can you all do? I'm going to tell you some techniques and tools that you all can use, you all can analyze to test your devices. Right? Okay. So today I'll be talking about the importance of testing. Right? Why you need to test your products. Then I'll be talking about types of industry testing, which is the most important part for you all. Right? How are you going to test your products? What tests are you going to run? Right? How are you going to plan your testing process? Right? Firmware and hardware both. And then about embedded systems design process. The life cycle of designing your embedded system. We're going to start, the middle, and the end. Okay? Right. Guys, I think the slide is now moving to the next slide. Okay, better. So why testing is important? Now if you look at any product, if you don't test, it can be a problem. If you write a firmware, what do? You test it. You run it several times, you test it. Right? So testing plays a very key role when you're developing any product. Just get a basic example. What if there is this light? A LED light. It has some circuitry in it, right? You know that LEDs use DC voltage and there is a little circuitry. What if they never tested this? Because it's just a light, right? What can go wrong? And the moment you get a light and then you put it in, your breaker goes off. The whole house is dark. Right? Or this, another thing that could happen, you buy 10 bulbs, 9 works, 1 breaks down, will you be happy? To your house, you buy 10 bulbs, 9 works fine, 1 breaks. Are you happy? You buy 100 bulbs, 1 breaks down. Are you still happy? Probably happier than, 1 in 10, but still 1 out of 100, you're losing it. Now, if you reverse the role, I'm the owner of the bulb company. My engineers are designing the bulb. My engineers tell me for every 100 bulbs, 1 bulb will be damaged. Me as the owner of the company, or me as the shareholder of the company, should I be happy about it? Because imagine you're not going to sell, as a company, you're not going to sell 100 bulbs. You will sell 100 bulbs in a day, or probably 1,000 bulbs in a day. So the loss for you as an investor is big. So all of your products, each and every one of you are developing products to be, you have a vision, right? How many of you wants your products to be like full commercialized? Anyone? Raise your hands if you want your design to be commercialized. I want my design to be sold on the market. I want my product to be sold in mass scale. No? No one? Okay, I see a few hands. I want to see my product selling. Okay. So about 75%, thank you very much. 75% of you are planning to sell your product. If so, you have to think on that aspect as well. How are you going to assure that this product is going to last? Right? So these, the same things that I told you in point form. Right? You have to make sure your product is reliable. You put a bulb, you put 10 bulbs, are you going to assume that one is going to break off? How are you going to have your quality? You put a bulb, you tell in specification it's going to be about 1,000 lumens, but actually it's about 500 lumens. Have you seen bulbs to be sold now? LED bulbs in a proper company is about, a branded company is about 900 to 700 rupees, a 7 watt LED. But you have seen people on the road selling LED bulbs for 150 rupees, right? 150 rupees, 200 rupees, right? Have you ever thought how and why? How can people one company give a bulb for 400 rupees, another person can sell an LED bulb for same wattage for 120 rupees? Why do you pay more to buy it from a branded company? Because you know that the branded company has some reliability. They manufacture products that would last. At least you assume that. And the bulb you buy for 150 rupees will not last as long. I know some of you, if you have tried it, you know that. There is a small rattling sound coming from inside. It could damage your entire grid system. And sometimes when you put those LEDs, your TV starts showing lines also. Why? Because those circuits that convert AC to DC are not good enough. And they are causing issues in your grid. And it's bothering other equipment in your grid. So it's causing more damage. So that's why you spend extra. Right? So your product has to be having quality. And next is compliance. So we'll talk about what compliance is and how you can come up with compliance standards. Right? A famous company compliance standards in Sri Lanka is SLS. Of course, there are other standards called ISO, FCC, right? So there are different standards. Of course, you all as students might not go this far, but it's important for you all to know. Maybe in your product, when you pitch your product, right, at the evaluation, when the evaluators come, you can say, my product supports these standards. I have researched standards for ISO 9000 standards. My product supports ISO 9000 standards. My product supports SLS standards. Now, if you are planning to sell a product in the UK, you can't come and say my product supports SLS. Doesn't make any sense. Right? You have to find out what UK standards are. Right? So we'll talk a bit about that as well. And of course, cost and time saving. You build a product with issues and you mass produce a product with issues, right? It would cause a lot of damage. I don't know if you all remember, some time back, there was a famous phone company that launched a phone that exploded, right? And that cost about billions to the company in damages and restitution. Why? Because some engineer, I usually talk about the story, I didn't include that story, but some engineer didn't put the proper battery into the phone. They put the wrong battery. As a whole electronics analysis of why that happened, but somehow or another, some engineer made a mistake and cost billions, and more than that is the reputation. Forget about the money. The reputation loss, because you know, if you look at mobile phones, there are two main companies that are currently leading the market. And if one company makes a blunder, the other company gets a significant edge over reputation. So if you are selling your product to a reputed company, they would want to know if your product is reliable and cost effective, because you're playing with the reputation of a company. Right? I'm not going to mention company names. If you're making a solution, if you're selling it to any company, mostly a reputed company, they would look for it. Right? And they don't want their reputation tarnished. So it's very important that you think about this when you're designing a product. Right. We'll talk about tests one by one. How many of you have an electronics component in your product? Electronics component. There's electronics component. Okay. All of you all have electronics component. Okay. So basically, you have a circuit board. You're going to have a circuit board, some sort of. Either it's going to be a printed circuit board, or it's going to be a dot board with some pieces soldered onto it. Right? So what are you going to do? You build the circuit, right? You fix all of the components together, or you get it manufactured from China, bring it back, right? And then you solder your components, taggala gahana power ekata. And then you see smoke going. That's what you're going to do. You don't, right? You don't bring the board straight away and power it up. So there are things that you have to do before you power a board, right? So board bring up testing, right? Peripherals and memory. Specifically, you should start with the power supply. You should make sure the power supply you designed gives the proper voltage. Assume you designed a 5-volt power supply. Are you giving 5 volts? Are you giving specifically 5 volts, or your 5 volts is going like this? Some circuits doesn't mind the 5 volts going like that, but some circuits are sensitive for the 5 volts going like that. And if you are if you are doing some sort of electronics, there are enough and more ways to smoothen out this effect. We call it the ripple effect, a ripple voltage. You can use a capacitor or something of that sort. And there are enough and more power supplies. So also you have to consider about the clock, right? The oscillator. Are you giving the right frequencies? And the peripherals. If you're having an I2C line, a common mistake I have seen is, I don't know if you all know about I2C lines, who have heard about I2C lines, I squared, okay, most of you know. So if you have multiple I2C components in the same rail, you have to have I2C is normally pull up, right? You have to pull up with some resistor. Some people mistakenly pull up 3 times. At every component there is a pull up resistor. This would cause a power loss in the system, and all of a sudden, when you try to integrate a couple of I2C devices, your system is not working fine. 2 of your peripherals are not working fine, and you're lost. Right? So these things you have to think about and analyze separately, not together. You separately analyze the peripherals, separately analyze the power supply, separately analyze the oscillator. Then you put them together one by one and power the board slowly. If not, you first start powering the board, picture no never picture liverai. You'll probably burn half of your circuit without knowing. You all are students, you all can make mistakes. That's true. We can make mistakes too. That's why there's a systematic way to do this. Right? Next, let's talk a little bit about firmware. So obviously, again, if you are having any electronics component, you are going to have a firmware component into it. You're going to nicely code it. Right? Your codes are going to look nice. Now, there are different ways to debug firmware, right? So these are few techniques that I came up with, and things I use mostly to debug your firmware. So you can have debug points. I hope you all know what debug points is. It's basically a point in the firmware where you can run and stop and visualize the variables. Right? There could be a point where some variable should be 1000, but it's never 1000. You racking your brain to see why is it not 1000? It's 10 instead of 1000. What has happened? So by using a debug point, you can go step by step in the code and see where is it 10? Why is it not turning 1000? What mistakes have I done? Right. So debug points will help. Right. If you're going in assembly code, that's a whole different way. And then you can look at your stack, your register, your memory. Right. Because when you're having a microcontroller, so most of you all will be having a microcontroller, it's important to know how much memory are you using. Anyone who has done embedded systems knows that microcontrollers have limited memory. So limited memory means limited resources. And when you are allocating memory, you can't go to the edge. You have to make sure that your memory is within a healthy limit. Right? I know some of you in your PCs, in your hard disks, are baraka ratu vela deyanna. You have pushed it to the limit. Right? And in your phones, there's only a couple of MBs left and your phones are struggling to open an app. Right? So you can't have a similar system or a similar way to your microcontroller. Because, ladies and gentlemen, your microcontroller is not as advanced as your phones or your laptop. Your laptop will find some coping mechanism and give you a warning at least. But your microcontroller, the only warning it will give is it will freeze. Right? So imagine you as a product developer developing something and your microcontroller freezes. Right? Your microcontroller freezes. I know one team, I think the team that won last year designed a water collecting mechanism for a water tank. Right? And imagine, so their whole system was how to measure a water consumption in the water tank and giving out water and the whole thing. I think they won last time. So imagine your system gets stuck with the valve open. Then tank off karannat bad, the valve is stuck open, it's overflowing. Right? Normally you can close something, now you can't close something because you automated the system. Right? It's going to be a mess. So a system being stuck at the wrong time can be dangerous, messy. Best case it will be messy and it will be fine. But worst case it could be dangerous. Right? So in general, guys, don't push your microcontroller to the limit. Know the memory allocation, know your stack and see how you can move from there. Right? Right. So these are things that you can do. You can do your code reviews. When you're doing code reviews, don't do it yourself. Get someone to do it maybe. Get your colleague to do it. Right? You check out what your friend do and get your friend to check out what you did. Because when you write the code, you're thinking something in a certain pattern. And you will always look at the code in the same pattern. And you won't find your errors. But your friend is thinking in a different pattern. Right? So more reviews you get, the better it is. Right? So get reviews done. And try coding standards. So there are different coding standards. So if you're using C++, there is something called Mistra code standards. Just search around. I'm not asking you to go stick to the standards, but that's the industry standard. If you can stick to that kind of a standard, that's really good. Right? It shows that you know what you're doing. Standards. Right? And then you can use diagnostic firmware. What's a diagnostic firmware? If I go to the same example where the water motor is automated, you can upload a firmware to your device to check all the hardware only. It's a separate firmware for diagnostic purposes. What is diagnostic? What's the word diagnose? Doctors like diagnose karna. Right? So it's like a full body check. The only thing that firmware does is it will check if the valve opens, okay, valve is okay. LED brights, okay, LED lights up. Okay. If your power working, power is working. Is your memory works fine? Okay, that's also working fine. Is your EEPROM working? EEPROM works fine. Right? Is your motors working? Okay, motors working fine. Even in your phones, there is a diagnostic app. You can install the diagnostic app and you can test different sensors in your phone as well. Right? So these things can be done to better your system. Right? And of course, you can have test-driven development. That means you write your firmware in such a way that you can test it. You can run it in such a way that you can test the system in your firmware itself. You built in test to your firmware. Right? Like separate functions. Those functions run, when you give some combination, it will run. Self-diagnostic. Right? And of course, unit tests. Unit tests, some of you might have heard in the software industry, you can do it to firmware as well, where you test segments by segments. Unit by unit of your product, you test it. Those are called unit tests. Yeah. And then of course, static code analysis. So SonarQube is also another tool where you can use to analyze your code. Are there any variables that are unused? So most of your IDEs will do it for you. Right? IDE is an integrated development environment. VS Code is another IDE. Okay. FYI, if you don't know what an IDE is. Embedded systems security. Yes. Again, guys, your system is supposed to be secure. වතුර මෝටරේ ඔයාට දාන්න ඕන මිසක් එහා ගෙදරක කෙනා වගේ වතුර මෝටරේ දාන්න ඕනේ නැහැ නේ. Right? If you're developing a IoT automated system for home lights, you don't want your neighbor controlling your lights, right? You don't want your friend controlling your lights. Right? You want you and your family to control your lights. Right? So how are you going to get that security? Right? And also if you are developing a product, a final product, right? Now let's say again, you make your whole system secure, right? Your water, I'm going to go with the water motor example because I can use it for different examples. You make a full automated water tank monitoring system. Very nice. Your neighbor comes on නැති වෙලාවට හොරෙන් ගෙදරට පැනලා. Now your system can't be hacked at all, okay? Like Wi-Fi is secure, everything is secure. But when you're not there, your neighbor, who is also electronics engineer somehow, comes to your place, right? Shape puts a USB port into your microcontroller and puts his own code in. Right? Now his code is running in your device. So can this happen? Can you expose USB ports or debugging ports in a final device? Right? Another good example is, I don't know why that's happening, but another good example is, most people use this, is unlocking routers. Thank God person from Mobitel is gone. But unlocking routers. Now, if you know the basic routers that you have, most of the routers, they have a firmware. That's how it's locked. They have a code inside it. More like a software. It's a Linux software that's running. So what these people who are unlocking does is, they tap into this software to change it. But most of your routers have blocked the place to tap into this software also. Around router, if you remember, there was a router with a single antenna, like a blocked router, which had a single antenna router with a battery. It came with a battery also. That router, there was 4 holes where you can tap into the router and upload a different code. Right? Modern routers, they don't even expose this hole. Right? So you can't even think of breaking locks or coding this. Right? Sometimes you can do it. You can do it with the USB port as well, but it's not that easy. You have to do some hardware changes. You have to do some changes. So why do these people do this? Now you can't just log into your AC and change the firmware, right? AC eකට radio එක firmware එකක් දාලා සින්දුහන් doesn't make any sense, right? But there are things that you can do. What if your AC breaks or AC firmware gets corrupted? I don't know if that happens. How are you going to upload a new firmware? Obviously there should be some way, right? Because when this PCB was manufactured someday, they uploaded a firmware someday. But they have made sure that you can't upload one. So maybe there are keys or something, unique keys, security keys, encryption. So that's where cyber security part comes in. How are you going to make your system secure from all of these breaches, right, as a firmware developer, right? So again, you can have mechanical design. So so my project is currently, I'm working on devices where you do payments. Card එක දාන, if you go to supermarket, you give, or I don't know, supermarket or a clothing store, whatever, you go and when you get the card, they put the card or they swipe the card or they tap the card on a unit. So my current project in my company is, I am the one who developed firmware. So me and 3 others, we develop firmware for those devices, right? You must be asking why firmware, because in the lower level, I don't know, some of these may be security information, but this might be helpful for you all. So in the lower level, there is a microcontroller that is reading this card. The smart chip, can you give me like a card? Like, yeah, just any card. A card depend on photo, right? License card, yeah, if you, right. So if you look at this card, make a chip. Just any partner card. So in a card, right, there is this smart chip, and then you can tap and go, right? Some guys videotaping, so it's too bad. No, not expired card, no? It's real card. You don't use it, okay? I'll cover the numbers and show, right? So if you look at a card, guys, so there is this smart chip, right? And then you get the mag stripe, and then you can tap, right? So all of this information is exchanged through a microcontroller. There are separate microcontrollers for this purpose, right? If you look at your driving license, which there is a chip, and if you align that driving license with this place, the chip is in the same location as this card. If you get a SIM card, back in the day, SIM cards used to come in something like this. That SIM card also comes to the same place. If you keep this card and the SIM card together, it is also located in the same place of this chip, right? So all of these cards use the same method of communicating, right? There's a microcontroller that grabs this information and processes it and sends out. So that's a full end-to-end device. And all of the encryption keys that are used to decode this information is also in the same PCB, right? And this device is made in such a way that if anyone tries to put a screwdriver in and remove one of the nuts at least, the whole chip that stores your keys gets erased or damaged. And if you get the device, sorry, so if you get the device, so let's say if this is the device, so this is the top part of it, this is the bottom part of it, and if someone tries to poke a screw into this, there is a metal mesh underneath this, right? Mesh that is electrically connected. So if anyone damages that metal mesh, you can't use the device again. It's called tampered. That device gets deactivated, you have to go give it back to the bank and get a new device. So that is how they have secured it. You can't poke or mess or do anything with it, right? So now you all must be asking, how am I developing firmware for this device? They send us separate devices with fake keys, with debug ports outside, just for so that we can code this. But even I who are working on this project for 3 years, don't know the keys or anything related to that. There is one, so the only way that they authenticate is they have one laptop not connected to the internet. 3 people go with some keys and they put some fingerprints, and that's how they, now firmware, you have to push it off to the devices, you have to launch it out, right? That's how they do it. It's very secured, and there are specific secure states for that. It's called PCI DSS. So it's very secured. How secured? When you even declare a variable, you can't just declare a variable and let the variable go. You have to assign 0xFFFFF or something and destroy the variable within the function before you let the variable go. You can't even have garbage variables stored. So it's that secure. Those are the standards that they expect. So very interesting stuff. When you go to the industry, you get to apply this, right? I also know a little bit. There's more. So different cards use different keys. So American Express use different keys. We use we use Master and Visa cards. There are more cards called EuroPay, China Union Pay, and things like that. So all of those cards use different keys. It's a whole big story. But I'm sharing this with you. There are secure systems like that. And also I'm sharing with this with you so that you all don't sleep. Some of you all are asleep. Right? Okay. Bit out of time, so I'll quickly go through these as well. Network testing. Probably all of you are using at least one of these things in your solutions, right? And these things has to be tested as well, right? Your communication protocols and all of that has to be tested if it suits your purpose. If you are using Wi-Fi, does it match your requirement? Now, I know I'm standing too much stories. How long do I have? Am I out? Probably out. Never mind. I'll quickly go through this and forget the story. Again, guys, remember, don't overcomplicate your system. Right? Long story short, I gave a project to one of my students. I actually lecture at university, and gave a project to measure voltage and current and display it on a PC. Very simple solution. One of the students have used a Wi-Fi based system to do this. Wi-Fi is good, it works, but the problem is that is unnecessarily complicating it. Right? Using a ESP32, he has used Wi-Fi to push the data into the laptop and show it on a UI, a web-based UI. Nice system. But remember, if you use a multimeter, when you put the probes and check the voltage, you don't want the voltage after 3 seconds, right? You want the voltage instantaneously. So there's a delay. So it's about understanding that what the requirement is. It's real time. And Wi-Fi, it's good, but it's unnecessary. Using overcomplicate things. So I'm just telling you, don't put Wi-Fi just to IoT it. Right? So think about your solution as well. Right? Okay. Yes, these are the compliances that I was talking about. So there is PCI DSS, safety. You might have seen some of these on your devices as well. So ROHS compliance, USB certified, lead free. Right? If you look at most branded components, you look at you behind it, your laptops as well. Even if your headsets, some of your power banks, if you look behind, you might see some of these signs. So these mean that they are in these compliances, right? So ROHS means environmentally friendly, and there's lead free. So if you look at US has FCC, right? If your devices are used for US, most of them have FCC. If you look at iPhone and Samsung chargers, definitely all of them have FCC certification. So these are some certifications at different countries. And if your devices, if you're planning to sell it to certain countries, remember you follow those countries' regulations, not Sri Lanka. You're selling it to US, SLS gala hariyanne bedagut naha. So you should know what you're going to use depending on your country, right? So this is one of the products that we did at our company. Again, you can see FCC, and it even has details of the sub-modules that it's been using, right? So if you look at this is the RFID module inside this, right? And if that RFID module has FCC, now this whole component has FCC separately, but this RFID module has its own FCC standard registration. So if you are using modules inside your device, check if those modules have compliances, right? So it's important to understand your compliance flow, right? I'm going to talk about two types of tests in general that you all can do for your devices and test, right? One is Hall test and the other one is hash test. A Hall test is basically test to fail. So if you're designing a bulb, it's supposed to work at 230, you give 1000 and see. If at 1000, if your bulb is going to burn, should be okay. But what if it's 1000 small spike? if your bulb starts to catch fire at a small spike, is that okay? I don't, right? So halt tests are basically testing to the extreme. You bend it maximum and see where it breaks. Extreme testing. And then you look at hash test. Hash test is just beyond your amount. So example, if your bulb is supposed to work at 32 degrees Celsius, you try to see if what happens at 40 degrees Celsius for one day. Does your bulb get damaged? Does it go off? What happens at 400 volts? For about 1 day, 2 days, 3 hours, what happens? Right? So that is halt testing, or hash testing. Right? So to give you a better picture, this is how it works. So if your device is supposed to operate over here, you do the hash testing just away from what's its normal operation. Right? Bathroom water, if your pressure is normally some PSI level, water pressure, you try a little bit more. What happens? Right? Halt testing is you try until it breaks. At what point does your device breaks? Cadena point. If your tire is supposed to go for 40 psi, 30, right? 40 psi, you see at what time your tire explodes. This is dangerous, but that's your halt test. Hash test is at 40, if your tire is supposed to be at 32, at 40, does it damage the car? Does it give good ride comfort at 40? What performance is at the edge of its normal usage? Right? So this is hash versus halt testing, and how you're going to test your device as a whole. Right? And the last thing I'm going to talk about is the embedded systems design process. Right? So most of you all are going to start with a concept. Maybe you're sleeping, when you're having a wash, you'll be like, life would be easy if this solution is there. So that's your concept. You think about it. Then you do a POC, proof of concept. You put some wires together, right? And some of your devices, even at the evaluation stage, could be a POC. That's fine, right? But the next steps are where you think deeper, right? EVT is electronic verification. You do the electronics, you do the circuits, then you check the circuits separately, right? So if you're designing a bulb, a Bluetooth bulb holder, this is where you put the Arduino and some stuff with jumper wires, and from Bluetooth, it works fine. There's some wires on the board and everything is all over the table. This is where you build the PCB. You do the circuit and you test it separately. Then you do the design verification, right? You do a Bluetooth bulb holder, and if it's this size, do you think people will buy it? If you design a Bluetooth bulb holder and it gets heated to 40 Celsius, do you think people buy it? You design a Bluetooth bulb holder, it's black in color, do you think people would buy it? Design verification is where you think of how the design looks, how the outlook. Will people buy it? Right? This is your design. Right? What materials are you going to use? What is the texture? What does it look? So this is design verification, where you verify design. And finally, your production verification. Right? When you're designing your system, designing a system, to remove the batteries, you have to remove 4 screws and remove the whole thing off, just to replace the batteries. Is it a good production design? Right? You have 2 parts to be fastened. You have 20 screws to put these parts together. Is it a good design to manufacture? Because remember, at production, every screw will take time to put in. And a 10කින් කරන්න පුළුවන් and a 5කින් කරන්න පුළුවන්. But if you use 10 screws, it will take more time to produce. Right? So how can you make this producible? Right? Your design is fine, everything is fine. You source one component from Uganda, right? It's only manufactured in Uganda. I don't know why I chose Uganda, but you know, right? It's only for Uganda. So, is it a good design? If that company in Uganda fails to manufacture it, you don't have an alternative solution. So your production is going to stop. You're dependent on one component, one specific component from specifically from Uganda. ඒක නැත්තම් ඉවරයි. So can you manufacture that? No. So remember these things as you're going to design a product. You have to design this product to be manufacturable. It has to be used by people. People should like to use it, right? You're designing a bulb එක හොඳයි ඔක්කොමත් හොඳයි. It takes about 40 watts. Again, no point. Your water treatment system, it's good, perfect, but bill එනකොට people are going to get annoyed for the light bill because it's going to consume a lot of electricity even in the standby mode. So that's a bad design, right? So these things has to be considered because engineers are not going to be using this. You have to think in a point of a normal person, non-engineer, non-technical person. How are you going to do that? Get ideas. If it's a water motor, right? Go ask from people. Go ask your friends. Because they will give you honest opinions. They will give you non-technical honest opinions. You ask a friend from a different faculty. What do you think? Right? Or you can do a survey. You can ask people randomly, I don't know, at a certain level. You can do a survey, even at campus or this is our device. What do you think? Make an answer. This is nice. Would you use this? They will ask, okay, make okkama hondai gaana kiyada 10,000 light ekak. Huh? 10,000 light? What? So again, think. Right? You have to suit the market. 10,000 for Sri Lanka is too high, but 10,000 for US, it's about not even $100. It's about $30, I think. So, see, you have to think everything. That's how you do a good product, right? All right, ladies and gentlemen. So finally, I have to conclude with this. This is my contact number. All of you, if you want to ask questions, it's my QR. Automation applied to an inefficient operation will magnify the inefficiency. Just because you all want to design something for IoT, don't just do a solution for something that is useless. If the operation is inefficient and its own, you design a solution, it won't be a good solution. Right? වැඩක් නැති දෙයකට solution එකක් හදන්න එපා. Think of it, think all of the stuff I told you, right, and design a good product. Maybe you won't win, but if you have that drive, maybe your product will be on the shelf. First tapo කෙනා කෙසේ වෙතත්, first tapo superstar කෙසේ වෙතත්, second tapo superstar success වෙන්න පුළුවන්. It's your drive and your passion that will make your product go, right? Some people, they'll win the first place of any competition. I'm not talking about even this competition at all, and they'll forget about the product. Api dinna, we are done, right? Maybe the people who came third or people who didn't win, their product will be on a shelf someday, like Shark Tank. If you know, you know. There are enough and more cases like that, rejected by Shark Tank, are doing well, right? So it can happen to you. So don't do it just for the competition, continue it even after the competition, right? And you all will have your products out there. So I wish you good luck in your devices, in your work, in doing this competition, right? And if there's anything, you can always reach out. And if there's questions, I think in the panel discussion you can ask. So hopefully I'll see you guys soon. So thank you very much.
Thank you, Mr. Ashin Fernando. That was indeed an enlightening session. Now, moving on, please join me in welcoming Dr. Chaturanga Hettiarachchi, a senior lecturer at the Department of Computer Science and Engineering at the University of Moratuwa. His research interests include IoT sensors, embedded systems, edge computing, and pervasive computing. And he has contributed significantly to advancements in these areas through publications like Self-Healing and Self-Adaptive Management in IoT Edge Computing Infrastructure. Dr. Hettiarachchi is also dedicated to education, actively engaging in postgraduate programs and guiding the next generation of engineers. His commitment to both research and teaching makes him a valuable individual in the academic community. So let's all give a warm welcome to Dr. Chaturanga Hettiarachchi.
All right. While the slides come up, yeah, let's have a chat. So, yeah, so glad to see you all here. So, hope you have selected the project and you are progressing with it. Some idea you have already. So, I'm going to talk about sensors, right? So, in any IoT project, right? So there are a number of components you need to put together to make it IoT project, right? So you need some kind of sensors, probably actuators, and of course there is a processing and communication, right? So now when you are thinking about like what kind of project you want to do, right? How would you come up with the project idea? Maybe you came up with some existing project ideas, right? What can be done, right? But when you actually try to select a project, right? You have to think about feasibility, right? Whether it's possible to do, right? So in terms of communication, IoT, of course, internet, some kind of communication should be there, right? But you know that nowadays a lot of equipment, maybe microcontrollers, development boards, number of things are available, right? So that is not a problem to communicate. Of course, if you need higher bandwidth, if you are using maybe a video camera in your system, right? You might need certain bandwidth, but essentially, if it is IoT device, right? So the connectivity is the fundamental thing, and it is already there, right? If you need higher bandwidth, you have probably a better way of communication, right? So if you have Bluetooth, for example, you can go with Bluetooth, and you can communicate for a number of maybe meters, right? Then also you can go with Wi-Fi, but if it is somewhere far away from typical networks, probably you can go with maybe a 4G network or another type of long-range network, right? So now, okay, so communication is there. What about the sensors? So what kind of sensors would enable your project, and how to select it, right? So that's what I wanted to talk about. I think this is supposed to work. Okay. Okay. So yeah. So when we select sensors, you have to think about a couple of things, right? So as I said, whether it's viable, like let's say you have a project idea, but do you have a suitable sensor to detect whatever the quantity you need to measure, right? So I think when it comes to like typical projects, right? Let's say you are automating something, you are measuring a current going in a certain plug point, right? So now probably you have to do a certain research and find out what are the sensors available for that, right? So how many of you have selected by maybe a component name, what are the sensors you are going to use in your projects so far? Can you raise your hand if you have selected, okay, I know this is my exact sensor I'm going to use in my project? Okay, so yeah, so hope this will help. This will be helpful then. So the idea is that when you are choosing a sensor, right? First thing you can do is, of course, you can go search internet, right? So you will find some of the things which are meant for typical projects, right? So IoT projects. But then you have to think about whether it is accurate, right? How accurate it is. And also, maybe you are building a device which is going to be deployed without wires, right? I mean, wiring, I mean, what is the Internet of Things? Everything is connected, right? But everything, it does not mean everything is wired, right? So then essentially, most of the time, you might not get I mean, let's say you are building a smart doorknob, right? You need to unlock your door, right? But are you going to wire it, right? So maybe you need to run things on batteries, right? Let's say it's a vehicle, right? You might need some kind of battery life, right? So in terms of product viability, it should probably cater to your energy requirements, right? There's a battery, then what is the budget of energy? I mean, essentially, how much current your sensors could draw, right? Probably you will have to have an idea, right? Then compatibility, right? So when you are designing, you need to think whether it is compatible, right? Maybe you are designing an IoT system, maybe for a factory, right? In a factory, you might have maybe tens of devices, right? 10, 20, 30 devices, and you need to wire all of them or connect all of them to make it a smart IoT system, right? So now, are you going to build individual devices for each one of these sensors, or are you going to connect them to a centralized place and do whatever the processing there, right? So let's say, okay, so let's say one-to-one device mapping, one-to-one device and sensor. So how are you going to connect it, right? So you know, we have discussed, Ashen also mentioned, that number of protocols are there, right? So it could be maybe a digital communication protocol, but some of the sensors, right? Let's say you need a very high precision, some properly calibrated sensor, right? Then it might not have a proper interface which will go with whatever the I2C or such protocols, right? So then how would you interface it, right? That's also something you need to think about, right? Then after all, there is a cost factor also involved, right? Most of the things which are marketed as IoT sensors, you can order from AliExpress or wherever, right? Those might have some, they are meant for, most likely for kind of student projects, right? If you are going for production, right, you might need to think, as previously mentioned also, will this be available, right? And will this be reliable for a long-term production, right? So also the cost, right? So you have to think about these factors as well, right? So now another thing is calibration, right? So I used to say that, like, if you want to build something new, right? If you want to, let's say you are building a new product, most likely you need to seek a patent, right? You are going to get a idea out, and you are saying that you are the first one to manufacture it and put to the market, so that you are reserving that for yourself, right? So nobody else can manufacture it other than you, right? Without your permission. So if you are going for something like that, right, then you might need to think all of these factors, right? So now, for example, if you think like that, right, now most of the common things which you encounter day to day, right, those might be, somebody else has done it, right? Maybe last year there was a number of IoT projects. Previous year also there were a number of IoT projects, right? So if you want to find a project which might not have been patented yet, right? At this level, probably we are not expecting you to build a patentable product, but have a vision a little bit, right? Think that if you can find some, let's say it is meant for a very high temperature range, for example. Or it could be we need very high precision, which is not existing today, right? So then you need to probably look at some of the novel sensors which are coming on into the market, right? Or maybe some of the things which are pushing some kind of boundary, right? So it enables the market so that when you are building IoT devices, those could give you a advantage of like probably going first to the patentable product, right? So yeah, of course, as a beginning, you might use this kind of sensors, right? You can, in AliExpress, you can order this set of sensors and they would do quite a lot, right? Actually, they have like sound detectors, touch sensors, and a huge number of different sensors, right? But what's beyond that, right? That's I wanted to talk a little bit further, right? Okay, so now let's take an example, right? Simple temperature sensor, right? Temperature sensor. I mean, if you take whatever the IoT, I mean maybe a microcontroller, microprocessor, I mean whatever the single board development tool, right? Development kit, you might get a temperature sensor within that sometimes, right? But now how would you choose? Are you going to use that, or are you going to look for other sensors, right? So now if you consider the range of sensors available for temperature measurements, right? So you can find variety of sensing technologies are there, right? So if you are developing a system, probably you need to think and find out which one is the best for you, right? So most of us are currently probably based on our home, right? We have experience in our own setup, right? But if you look at as I said, right, where our product can be marketed to prepare some maybe